Determinants, 2x2s. We're going to do 2x2s today and tomorrow, and then we're going to do 3x3s. I honestly think that doing the 2x2s are easier to do in your head than they are to put into the calculator. However, when you were doing your research yesterday, can anybody remember anything about how to find the determinant of the 3x3? I know some of you looked at it because it had like...
You can multiply something in the 2x2.
Yep, we're going to multiply, right. But then when you had a 3x3, do you remember what you had? Because there was a picture and it had like this, and then you had this. Do you remember this? And then you had this, and then you had to draw a diagonal that way because you added rows to make it a square. No? All right, well, we'll talk about that. I'm going to show you how to do a 3x3 by hand, but I'm going to let you do them in the calculator. I'm not going to force you to do it like other than once with us together, okay? All right, so bottom line, we're doing system of linear equations, right? And you can solve it by graphing, because we would like graph the two equations, and that intersection point would be the solution, right? Okay. Then we did it algebraically. What was two methods that we did when we were doing them algebraically? Very first ones that we did. Starts with an S or an E.
System of equation?
No, that's what we're talking about. It's just substitution.
Or elimination.
And elimination. Okay, perfect. And then what was it that we just got done learning about? Not the matrices is everything, but what method did you guys use? Row echelon and reduced row. Perfect.
What the heck is an echelon?
I don't know. It's probably some guy's name. You know what? That's a good question. Look it up. I'll give you a bonus point.
Wait, system?
Okay, so she had a great question. Okay, so another method for solving, and what we're going to learn is called Kramer's rule. Anybody find out anything about Kramer? Not the guy from Seinfeld.
I was about to say that.
That's actually K.
That does start with a K. Anybody? What was his first name? You were supposed to look that up.
Gabriel, yeah.
Gabriel, right? Who was he? Anything?
A mathematician, professor.
Okay, I was going to say, I hope he's a mathematician.
It happened in 1750.
Nice, okay. We'll go with that. All right. And this method uses determinants to solve a system, okay? The method is best used when the solutions to the system are one solution. Okay? Alrighty. Now, what is a determinant? Good reading. It is a square array, okay? We put them with parallel bars, and we calculate by finding the difference. That was the difference of the products of the two diagonals. So that means I do A times D minus B times C. Okay. What was the symbol or notation used for the determinant?
It's like DET. Yeah, and then wasn't there a parenthesis and then A?
Kind of. And actually, it would just be, you could use either just D. You could do the DET. Usually they use DET when they're talking about a specific group, like DET of that means the determinant of matrix A. Okay? But the symbol notation is just D. All right? So to calculate the value of it, we are going to multiply, because it goes A, B, C, and D. So we multiply -4 times 3, and then subtract 2 times -5. And so we get -12 minus -10. And so our determinant is -2. That really is how easy it is. Easy peasy, right? That's why I was saying that once you do a couple of them, it'll take you more time to enter the information in your calculator than it would to just use your head and calculate it out. All right, so let's do another one. What's my equation going to be? My determinant is going to be what? 6 times 3, perfect, minus 4 times -1. Okay, so 6 times 3 is 18, minus -4. So my determinant is 22. Okay, so somebody ask me why we care. Why do we care? I mean, what's the determinant tells us? Okay, determinant's 22. What's that mean? Yeah, who knows? All right, let me tell you what it means. This is why we care. Okay? All right, little recap. We have Kramer's rule, and it uses the determinants. Okay, there's a couple rules for Kramer's rules. All right? First off, has to have the number of equations have to equal the number of variables. That means it must be a square matrix. Okay? So you can't do it on like a 3x4. Has to be a 3x3, 2x2. Okay? So like 2x2 and 3x3. Okay? You primarily only works for 2x2s and 3x3s, okay? It's what, did anybody see the part in the research about, it said something about it being numerically unstable? It's like on the first page of Wikipedia. Does anybody know what being unstable means?
I remember those zeros. Zero. But I don't think that.
Well, but what it means is, like, remember, like, when Pythagorean's theorem was, they were trying to prove that in math, you have to prove it for everything, right? So when Pythagoras was doing his theorem, he had to prove that every triangle would always, always, always end in this, okay? That's a stable theorem. That's a fact. That's a law, because they proved it no matter what. If it's unstable, it means it works for the majority of the time, but sometimes it's not going to work. And so what happens is that we need to use it when the solutions are one solution, okay? But if you get D is equal to 0, okay, that means that it doesn't work. It's unstable, and so you can't use it. So if you get your determinant equal to 0, you can't use it. And that means it doesn't tell you it's all solutions. It tells you then it's either no or all. You got to use another method to figure out which one it is. Okay? So it tells us all or no solutions. Use another method to figure. Okay, does that make sense? So, what is Cramer's rule? It says that if we have the system of equation, and we're going to write it into our augmented matrix. Okay. Now, what do you notice on the first part of it? Where did we just see that? That was the formula for our determinant, right? Okay. So what it says is that you can calculate out for x if you use these rows from your whole augmented matrix and then divide it, find the determinant of this, determinant of the whole thing, and then divide them. Okay? So, here's what you do. We're going to, so we need three things. We need a regular determinant, and then which row do we replace in this top part? Do we replace the x row or the y row? See how it went A, C, B, D? From a regular determinant? So I replaced the x row right there, right? If you look at your system, you got x, you got y. We'll call that the total column. Okay? What did we replace the x column with? The numbers from the total, right? And then in the next one, which column did we replace? The y. We did it with the totals because we were looking for the y. Okay? So basically what they're saying is that we can find, if we find the determinant of x, we replace the x column with the total. We find the determinant of the y, replace the y column with the total. Once we find those three determinants, then we can just calculate out for x and y by dividing them. Stay with me, it's super easy. Okay, it just sounds a little complicated, but we're going to do some examples. So, first thing I need you to do is let's flip to yeah, I put this on backwards because it says day 2. Let's do another example first. Go to the third page. Obviously, I was having copier difficulties again. Okay, so my first step is to write the augmented matrix. Okay? So my augmented matrix is going to be 3, 0, and 24. Where did I get the 0 from? Yep, I don't have any, so that's... And then 1, 2, and 0. Do we all agree with that? Okay. Then my second step is going to be to find my determinant, which is ACBD. Oops, I just used 2 purples. Sorry about that. Messing up my color formula. All right, so my determinant is going to be this part right here. So 3, 0, 1, 2. And then, so that means that I have 3 times 2 minus 1 times 0. So my determinant is 6. Agree with that part? Okay, second step. Find the d of x, the determinant of x. Okay? So I need to, and that said, replace the x with my total column. I'm going to keep y the same. Okay, so this time I'm using this one and this one. And so the my x column. So the d of x is going to be 24 and 0, and 0 and 2. Everybody with me?
Yes.
Okay, so d of x, I replace, since I'm finding my x value, I replace the x column with my total column. That's where I got my 24 and my 0. My y column stays the same. So 0 and 2. Good? Okay. So that makes my d of x 24 times 2 minus 0. So the determinant of x is 48.
So does that mean that x equals 28?
Nope. That's the determinant. We'll get to that. One more.
We're almost there.
Yep. Okay, so now I have to find the determinant for y. Which column am I going to replace with my total column? The y column. So E and F goes in the y column. My x column stays the same. And so the d of y is going to be, x stays the same, 3 and 1. Y becomes the total. And so the d of y is going to be 3 times 0 minus 24 times 1. And so I'm going to get d of y is negative 24. Okay. All right, now the rule said, back on this page, that to find the x, I divide my d of x by my determinant. So that means x is equal to, because I'm going to solve. So d of x was 48, my determinant was 6, and so x is equal to 8. My y was equal to the d of y by the determinant. So y is equal to my d of y, determinant of y was negative 24 divided by 6. So y is equal to negative 4. And that brings me the intersection of 8, negative 4.
Oh yes, we're only.
What did I just hear from you? Yeah. Okay. Yeah, it's not, especially on 2x2s, once you get to the point where you can kind of just do them in your determinants in your head, it makes them pretty fast. All right, let's do another one. Okay, step 1, write my augmented matrix. So, 3, 1. Oops, I'm looking at the wrong one. Sorry. 5, 2, negative 1, 3, 13, and 12. Alrighty, step 2. I'm going to find my determinant of the whole system. And so that is 5, negative 1, 2, and 3. So my determinant is going to be 5 times 3, which gives me 15, minus negative 1 times 2, so negative 2. So my determinant is 17. Good?
Yep.
All right. Determinant of x. What column am I going to replace?
The X.
The x column with the total column. Y column stays the same. And so I have 13 times 3 minus 12 times negative 1.
Is it possible to be first?
No, it doesn't have to be.
Why would
Doesn't matter. Oh, it can be. That's fine. I just, either way, flip-flop won't matter. So I have 39 plus 12. So my determinant of x is 51.
Oh. Maybe I've seen it.
All right. The determinant of y. What column am I replacing? The y column. So 5 and 2 stays the same. 13 and 12. So I'm going to get 5 times 12 minus 13 times 2. So I get 60 minus 26. So the determinant of y is... And let's solve for x and y. Good? Are you all with me? So, x was the determinant of x, so 51 divided by the determinant, which is 17. So x is 4. No, not 4. What is it? 3. Alright, and d of y is going to be 34 divided by 17. So y is 2. And so my system is 3, 2. Huh?
X equals what?
3. Okay. Okay. All right. So let's do the last one. What's my augmented?
3, negative 2, and 4. 6, negative 4, and nothing.
Perfect. All right. So what's my D? What's my determinant?
equals 3, 6.
Awesome. So what's my formula going to equal?
3 times negative 4.
Minus. Okay.
Somebody else stop that for me.
So 3 times negative 4, negative 12.
Yep.
Minus negative 12. Whoops, what, how did I just double that? Woo. All right, so what's my answer going to be?
0.
What's that mean?
It's either all solutions or no solutions.
Yes.
Solve it another
And
way.
think about this. Think about what we would be having happening if I had x is equal to d of x over the determinant. Can I divide by 0? No, that's why. So it's all solutions or it's no solutions. So What method can you go about doing to solve by? Well, you can throw it in your calculator and do the RREF if you want. Or you could go, hey, I can do it algebraically because I'm a whiz kid. And I'm going to multiply that by 2, negative 2, so negative 6x. So, what's my solution going to be?
No solutions at all.
It's ugly. We have no solutions, which means they are what kind of lines?
Parallel.
Boom, parallel. Muy bien.